All right, guys, welcome back. I hope you had a good week and a good weekend. We're starting a new week now, and yeah, I hope you will give some love to mathematics, show some love to mathematics. You gotta love the subject. You gotta love it. I promise you, at some point in the process of loving it, it will love you back. So don't do maths because you are forced to. You know what? Let me just share something with you, because this really saddens me. Okay, and that's why today we're not live. We're just gonna record this and upload it. Um, but one of the saddest things in last year's results, the class of 2025, it was mentioned that the pass rate is the highest that the country has ever seen. But what you are not told or what is not revealed is the fact that out of that 80 something percent of students who passed, about 13%, listen to this, only about 13%, approximately 13% have actually passed mathematics. And when we say pass mathematics, we're not talking about 40%. We're talking about something like at least 50% and above. Now, we are not even saying the number of those who got distinctions in mathematics. Now, that's a problem, that's a concern for me because it means that in as much as we have this high pass rate and a lot of students have passed, it is unfortunate that most of them do not qualify to go to university. Now, universities end up being forced to arrange a program where there's a sort of a bridging year between high school and university. All right. So there's some why some students will take a gap year so that they can actually upgrade their marks and become better prepared for university. So in as much as this high pass rate is celebrated, my question is the quality. And I want you to start questioning your goal for mathematics. If you aim to get 40%, you got to start questioning that because you might get that 40%, but you have eliminated yourself from being admitted to university. 50% cannot be an enough goal either because still there's someone who's got a 70% who might be preferred over you. So the goal in here should be at least a 90% or an 80%. That's how the standard is. And maths is like this. Maths is like sports. The more time you spend doing it, the stronger you become, the better you become at it. Of course, I mean, as you see in the sports, with the right coach, with the right resources, you go right and all that. So it is very, very important that you will set a high goal for yourself to say, I'm not going to settle for a 50%. If you are here and you are saying, I just want to get a 40% or a 30%, I'm so sorry. That's not going to help you because at the end of the day, you might end up being seated at home, not being admitted to university. There's no bursary, I can guarantee you, no bursary will give a student, well, no bursary will be offered to a student with a 30% in mathematics. It is actually easy to get sponsorships, but as long as you do well, okay? Universities credit you for your distinctions, in case you didn't know. If you get 7 distinctions, you can even qualify for the vice chancellor's bursary. I'm sure you've seen this when results are produced at the end. But I just want to do this little talk and say, guys, aim high. Aim high, you can do this. If your school is not a sporting school, you actually have an advantage of doing well because my question is, what are you doing with your time? When others are caught up with sports and all that, what are you doing? You should then rather be practicing more and more. So take this thing as a sport. And in sport, when you train, you do the running and all that, you become more fit and much better to do well in the final race or in the actual race. And mathematics is like that. We build on what we know previously. I need you to take this serious and make sure that you practice maths. Make sure that you find time to actually practice this subject, okay? And that's why some of you will realize it's not really enough to have the Sunday sessions. You still need to do your own. I say to students, you need 3 hours of personal time per week, not per day, okay? In 7 days. in 7 days of the week that you have, or maybe let's say 6 days, because at least you need 1 day to rest, you need to schedule 3 hours where you will do maths alone, without me here, without your teacher at school, without your friends, just alone. Because at the end of the day, what's going to happen in November? You're going to be seated alone, without a friend, without a teacher, without this Zoom lesson. And that's the goal, right? You're going to sit alone and write that exam alone and answer the questions alone. And so that's why I need you to practice now. Practice doing that alone right now. Okay? Practice solving problems, struggling with problems, and figuring out the solution right now. Please do not make it a habit that whenever you struggle, you run for help. Struggling is what will train you to develop what we call resilience in mathematics, where you will say, but there's no way this problem can beat me, can defeat me. I will defeat it. And as you will see, and as I always say, I'm sure you're getting tired of this, but I'm sorry, I'll keep saying it. Maths is a language. Pay attention to the words. Make sure you understand the words we use in mathematics, what they mean. And make sure you also understand the symbols which we use. We don't just throw symbols here. Just as your English teacher will penalize you for incorrect spelling, incorrect grammar, and punctuation, we will do the same thing in mathematics, okay? Some students lose marks because they don't put in the equation sign. Some students lose marks because they don't put the angle sign in geometry. You will see I'll emphasize this when we do Euclidean geometry. So I want to just beg you. Today I want to start off by begging you to take this subject serious. It is one subject that can literally unlock any door. You need 3 subjects, or at least 2 subjects. English, because it is the medium of instruction, you are taught in English, and mathematics. These 2 subjects can literally do the impossible for you. So please pay attention to them. Of course, you need life orientation as well, because you need to know what you want in life, right? They're checking that. But if you can prioritize these 2, master them, and make sure that you don't just do them, CPF, cram, pass, forget. You don't just do that, but you actually know what's going on. Doors will be open for you. You'll thank me later. Just try and get a distinction in maths and you'll see that. So please, I hope I'm dealing with those kind of people in this. You are not aiming for 30. You are not aiming for 40. You're actually aiming for 80. If you got a 30 last year, try double that. You got a 40 last year, try double that. If you got a 50 last year, try double that. It is possible because we have heard of students who got to double that. So it should be the same with you. Okay, enough about that. My apologies. I just had that burning zeal in me to actually just address this, say it. Once in a while, I'll just pause to talk about these, because some military motivation is needed. Even sports players, they get psychologists to talk to them before they play and all that. Right. So last week, we discussed inverse functions, and we spent some time talking about the inverse of the exponential function and the inverse of the parabola, the quadratic function. And I want to focus on these 2 graphs only today, because there's something special that happens with the inverse of a parabola and the inverse of the exponential, which is the log, by the way. So today, I'm just spending time on that. I'm going to start with the parabola. And I think I had drawn to your attention the fact that if you have a parabola, right, we know the parabola is in the form ax squared, right? It's a quadratic. So once you see power 2, exponent 2 in an equation, you know you are dealing with a quadratic. You expect 2 solutions. In the context of graphs, 2 solutions mean 2 x-intercepts, and so forth. So we know if I've got a parabola, so I've used this a lot. Today, let me just make this one example. If I've got a parabola, y is equal to 4x squared. Now, it is important to note that, as usual, if I want the inverse, we're going to swap. Then this becomes 4y squared. Now, because you are solving for y, y has degree 2, you must have two solutions. So I will start off first by dividing by 4 both sides. Then I have y squared is equal to x over 4. So the moment I take the square root both sides, then I get y is equal to a plus or a minus square root of x over 4. And this is where I explained, and I even showed you on the on GeoGebra, that actually two graphs are going to be formed here. There's one graph that will have the positive, so it will be positive square root over 4. And then there's going to be another graph that is going to have the negative, because we said plus minus, and it will be negative square root of x over 4. All right. Now, I'm going to just do a rough drawing of these two. If I draw the blue one, it's going to be like that. And if I draw the green one, it's going to be like that. And this has to make sense, because if you look at it, the blue one is on the positive y-axis. And that's why we had a plus here. And the green one is on the negative y-axis. And that's exactly why we have a minus there. All right. Remember, we are saying y is equal to x is always your independent variable. All right. And the values of y will depend on your x values. So that's why y is the range, which is a mapping of the domain under a certain rule or instruction. So these are very key basic things. You see, I'm saying basic, but little things can make big things. And those who do life sciences will understand what I mean when I say little things can make big things. So pay attention to these things. Now, one of the things I would have said is the fact that the inverse of this parabola is actually not a function. Oh, by the way, just for interest, if you draw the actual parabola y is equal to 4 minus x, it's going to look like this roughly. It will look like this. It will be like this. And we said, well, to tell whether a graph is a function or not, or represents a function or not, you just do the vertical line test. So this yellow line must touch a graph at one point at a time. And by that, I mean for one x value, for a single x value, there must be a single y value. Now, when you look at the inverse of the parabola, which is basically the blue combined with the green, that is not the case. For this one x value here, let us call this x2. For this one x value here, it seems like I have two y values. And this then obviously violates the definition of a function. So we cannot regard this thing as a function. And then I said, the key question then that they will always ask is, what should be the restriction on the domain of the original graph, that is the parabola, so that it will become a function? So if you look at the original graph, which is this one, currently the domain, we are saying we are taking all real numbers, meaning from negative infinity to positive infinity, we're taking those numbers. Now, obviously, we have a problem with the inverse because the inverse is not a function. Now, what we can do to make the inverse a function is we put a restriction on the domain. And this is how our restriction will go. We will either strictly look at the negative values, including 0, of course, or the positive values, including 0 as well. And this is where issues begin. Now, let's look at the first restriction. And I'm going to do this on a completely new slide. I want us to look at the parabola y is equal to x squared, where the domain is restricted to negative x values, including 0. If I sketch this parabola, and everyone has to know this off by heart. If you're not sure how to sketch, substitute a -1. In other words, take 3x negative x values because of that restriction. Just take those and just substitute them and see what you get. So obviously -1 will give me a 1, and a 2 will give me a 4. So this is a 2, that's a 3, that's a 4. So a negative 2 will give me a 4. So that means, roughly speaking, the curve will look like this. And now the question is, how is the inverse going to look like? Now remember, the inverse is a reflection of this curve about the line y is equal to x. Now last week I showed you two ways to do this. I said one way is just take 2 points. So we've got a point here, -1 and 1, and a point here, -2 and 4. So we will just take these 2 points and do what? And apply the rule y equals to x. What does the rule y to x equal to x mean? It simply means y must take the value of x must take the value of y. So, sorry, I'm not sure what I'm supposed to repeat. If you've got a question, maybe be more specific, Zoom user. I see your message, but be more specific on what you need me to repeat, please. You can type that as well. So now, what we're gonna do here is we're gonna swap this coordinate. So I had an x value which was a -1 and a y value which is a 1. So when I go to the inverse, the x value must become 1 and the y value must become a -1. So that means this will be my new point. We look at the point -2 and 4. So the x value must be a 4. The y value must be a -2, which is this one here. And I hope you see what is happening. Remember, this must also come from the origin, by the way, because at the origin, you have the point 0 and 0. And 0 and 0, you swap it, you still get 0 and 0. So now, in this case, you should clearly see that the inverse will have to go like that. And we'll just do this arrow to show that it goes on and on and on. Maybe it's not a nice arrow. So yeah, that maybe is better. And this will be your inverse under that restriction. All right. Another one, if okay, so you should know then what happens. If I give you x squared, and then I say, well, for this one, let's have the restriction x greater than or equals to 0. In this instance, again, I'm just going to have the symmetry of the black one. So it's just going to be that symmetric about the y-axis. So now if I sketch the inverse of this one, let's try and do this one in yellow. Again, take note, I've got the point 1 and 1. This is it's a tricky one, but it simply means this point 1 and 1 will be there in the inverse as well. So there's no need to worry about it. And then the other point that I've got here, I would have 2 and 4. So we know this one will become 4 and 2. 0 and 0 stays there. So now that means the inverse of this will actually go like that. So this is how the inverse will work under certain restrictions. Okay. Of course, we know the parabola is not only experienced as a happy face type of graph, it is experienced as a sad face type of graph. And I think I want to also illustrate what happens in such an instance. So if you've got a sad face, for example, y is equal to -x squared, and I'll do this one at a go. I will not restrict the domain. So I'm taking this for x is in R. So -1 with a -1, and then +1 with a -1 there. If we take a 2 or a -2, we will get a 4 because you are just squaring the 2, right? So that will be the next point. And if I've got that point here, I'll have that point. I mean, you know this property of the parabola. When you have one point on one side of the y-axis, you will have another point on the other side of the y-axis. As long as it is from the same distance, both points are the same distance from the y-axis. So that's the symmetry I'm using. If I know I've got a point that's 2 units there, there must be another point that's 2 units there. This is actually a nice, important principle to understand, because if I tell you on the parabola at -3, I've got -3 and a -9. Then you should know by default, you just reflect this point on the y-axis. Then 3 and 9 will actually be another, sorry, 3 and -9 will actually be another point on the graph itself. So it's actually a nice property that the parabola has. And I think students don't often take advantage of that. You try and go the long way when this simple property could have actually helped you. So take advantage of symmetry. If we had enough time, if we started this in grade 11, in other words, we could have actually went through the symmetry of the parabolas, talked about it, and see how it brings life to this beautiful function here. But anyways, let's continue. So if I draw this, the origin is there. It will be like this. And you must take note here, I've not shifted these graphs. So this is my graph. And again, you gotta know what should happen if you're going to take the inverse of this graph. In other words, if you're gonna reflect it above the line y is equal to x. What is interesting, I will just draw the graph, is that the graph that forms this time around is a graph that goes like this. Now, your job is to actually determine which part goes with which part. And if you paid attention, I'll show you this part here. If, in other words, if we restrict the domain to say we just want positive values, this part there here will actually go with that part there. If I restricted the domain and I said I just want negative values, then this part here will go with that part there. So it's important. Some said it's a bird and a fish type of situation. So I don't know if you see the wings or not, but that's how some students choose to visualize this. All right, this is obviously just theoretical. Now, I've got a question that I actually got from one of the past papers, and I want to take you through this and just show you how this sort of looks like in an exam situation. Right. We are given the graph f of x is equal to ax squared. Look at that, ax squared. Watch this, the domain has been restricted. So it should not be surprising. You should not be confused at this stage. I promise you, if you look at that statement and you are confused, it's a problem. It means you do not yet understand the language of mathematics. So we need to spend time and actually help you understand that language of mathematics, okay? Which means you might need some extra lessons there. Now, let's just have a look at this. So by just reading this, please take note. By just reading this, I already know that, oh, this parabola is only going to exist for the negative x-axis there, because they said x must be less than or equals to 0. That's what they said. So now I know, okay, that's what's going to happen. So this diagram then is not shocking. It's not surprising, because your reading here has actually given you a good picture. Now, we are also told that there is a point P with coordinates -6 and -8. The x value is a -6, the y value is a -8. So this point lies on the graph of f. So we are actually privileged. They have given us a point, which is good. We obviously know, since here x is less than or equals to 0, that means the origin is included. So we kind of have 2 points, although the origin may not help us that much, but at least we've got something to work with. Look at the first question. Calculate the value of a. Now, one of the few basic things that you must know is that whenever you're going to be asked to find an equation of a function, you are likely going to need a point. There's going to be something that will be given, and you'll have to use that. And this is the reason you are given point P, because you're going to need that. So to quickly sort out question 4.1, we will just say, well, y is equal to ax squared is our equation. You don't have to start this way. You can start right away with substitution. So point P, the y value, there is a -8. And for point Q, the x value is a -6. Let me just pause here and emphasize something to you, which I've said again before, and I will always preach this. You gotta use brackets whenever you substitute. You see, you're not gonna get away with not using brackets here. We see students doing this, and they get a -36, and you are thrown away already. You're not gonna get this right. Now we have to look at cases of continued accuracy, C, A, and C, if maybe you carried on with that mistake. But really, this can easily throw you off. So please be careful. Even when you plug this in your calculator, you cannot write it like this in your calculator. Let me then also go further and actually show you on my calculator how you would do this. You just open the brackets, -6, and square it like that, so that you get the correct value. You don't want to lose marks. You don't want to lose out on that A, on that distinction. And I promise you, some of you then end up scoring 79% because of such a silly mistake, right? You don't want to bite yourself over such. So please be careful when substituting. So this is going to be 36A, and that's a -8. So obviously we divide by 36 both sides. And again, if you are not sure what 8 over 36 is, I mean, some of you, remember, you are pressed for time, right? And sometimes the brain thinks it is thinking correctly, but it is not. So don't be shy to just press this thing. Okay, you rather be safe than sorry. So this is a -2/9. Oh, by the way, I had forgotten the negative, but I'm sure you know that negative divided by positive is a negative. So the value of A is -2 and 9. Now investigate the theory. Does this value of A, does it make sense for it to be negative? And let's go back to the theory. Yes, it makes sense that it is negative because we know when A is negative, I will have a sad face. So I should question myself. If I calculate the value of A at this point and I see that it's a positive, I must actually question my working here and say, but this is not agreeing with the theory, because the theory says when A is positive, this graph should look up like that. So then I should question, why am I getting a value of A which does not talk to the graph? So these little things, again, I want to say, are very, very important that we pay attention to. Okay, so this is easy 2 marks, right? Because we just had substitution. So we are done with 4.1. Let's get to 4.2. We want to find the equation of the inverse. Remember, this is not f to the -1, okay? This is f inverse, or inverse of f. That's how you read it. Find it in the form y is equal to something. So remember, your domain is restricted, right? And this is where the theory comes in again. If I have given you a curve like this, the question that you should answer is, how does the picture of the inverse of this thing look like? So this is the fish case. That's the one that's going to go like that. If they had given us this portion, then you must know that you're going to get that part. So again, this is the beauty of knowing the theory. And I'm talking about these two little things that I've explained when I'm talking about, when I say theory. When you are able to link this, make sense of this, guys, I promise you, answering questions actually becomes fun and easy. So how are we going to find that equation? Well, we now know the value of A. So let's just write down that. So y is equal to -2/9 x squared, right? That's what it is. And then the next thing that I'm going to do when we calculate the inverse, we know that we swap x and y. So I should probably have this as x is equal to -2/9, but then y squared. So I must obviously multiply by the reciprocal of -2/9. So that becomes -9/2x is equal to y squared. Now, remember, let's get this clear. When I was working with this, the domain was restricted to that. Let's be together now. Okay, so because it is restricted to that, I just want you to think and note that, by the way, this is one of the things I'm going to say, and I'm glad actually we did a problem like this. One of the things that happen when you find an inverse of a function is that what was the domain in the original becomes the range in the inverse, and what was the range in the original becomes the domain. So what happens is, the moment you switch x and y here, you must note then that you expect y actually to be less than or equals to 0. In other words, you expect this graph, the inverse, to appear or below the x-axis. This is what y is less than or equals to 0 literally means. It means the graph must be seen below the x-axis, because that's where negative values of y are. And again, as I said, you see, this is just the beauty of the theory and how things come together. Then it will make sense then why the inverse is going to look like that. So you just have so many facts that you can always use to verify whether your answers are right or wrong. So this is quite key. Now let's get the square root. So when we get the square root, watch this now. The square root, we know we usually take plus minus negative 9 over 2 x, right? Now, I know, again, another issue here is going to be, but hang on a second here. We can't have a negative number inside a square root. Well, you don't have to worry about that, because in this case, remember, this thing will exist on the negative axis. So guess what? Our domain is still that. Oh, by the way, this thing here is actually your range, because as you can see clearly, it's expressed in terms of y. So your domain is still that. And this has to make sense, because think about it, when you substitute a negative value here, that negative will be multiplied by that negative. So you end up having a positive number in the square root. And this is another check that will help you actually know whether you're doing the right thing or not. The moment you find yourself thinking that you can substitute positive x values, you should know then that your theory, or maybe, yeah, at that stage, your brain is contradictory to what the theory teaches us. So these are the little things that I need to pay attention to. Of course, we're not going to take plus or minus simply because we have one arm of the parabola only. So we're going to take this, and it is this negative. I want you again to take note. It is this negative here that will ensure that we are actually in line with this condition here that I had put in green. Because even though you may substitute negative values here, without this negative, you're just going to get a positive value, and that positive value will end up giving you an inverse like that, which is incorrect. So you need this, a negative there. So you need to be able to decide again, based on the theory, to say, okay, as I decide on the inverse part or on this plus minus story, am I actually taking a plus or minus? Your decision will again be based on the theory of or your understanding of how the inverse of a parabola works like. So this is very important to take note. Write down the range of the inverse. Guess what? In the process, we actually wrote down the range of the inverse. Y is less than or equal to 0. Now sketch that. I've already sketched it there. Indicate the coordinates of any point on the graph different to 0 and 0. So you see, they know that 0 and 0 is going to be there. So what other coordinates are you going to do? Obviously, the p prime. So there's going to be a p prime here. In this case, you just swap the x and y. So there has to be a -8 and a -6 somewhere there. If you like, you could also include this point of intersection where they're going to meet, but indicate the coordinates here of any point. So they don't want more than one point. So they did not say points. Remember, coordinates refers to the x and the y. So that's why it's plural, right? So they are not saying indicate the x coordinate or the y coordinate. They're saying coordinates, which means both x and y must be indicated. And they did not say points, they just said point. So we will stick to that point. We will actually just take point P, which they gave us, and we will swap things around instead of having to create another new point. Okay, let's read carefully then. The graph of f, in other words, the original graph that was given, okay, this one that I have highlighted in green. This graph of f is reflected across the line y is equal to x. So there is the line y is equal to x like that. I find this question a bit, I'm sorry, no offense, but it's a bit dumb, because how do you then say, maybe they are checking if you do understand that when you reflect this, you actually covered 4.2, or it is what you did in 4.2. I think that's what they're checking actually, yeah. But anyways, let's go with it. So we are told that this graph is reflected across the line y equals to x. And thereafter, listen to this, thereafter, it is reflected across the x-axis. Here's your x-axis. Determine the equation of the new function in the form y is equal to. You see, if you understand, you will understand that a reflection of this graph in the y-axis will just be that portion of the inverse that we did not write. So in other words, it will be this portion. Y is equal to the positive now, the positive of the square root, that which we had left. You will understand that's what they are referring to. Because we know the parabola is symmetric. Let's go back here. I told you it's symmetric. It's symmetric. This point here, even with the inverse, the same is happening. If this point is 2 units from the x-axis, this point here must also be 2 units from the x-axis. So that is actually what we're going to do when we reflect this, which means, think about this now. From the axis to here, this is a vertical distance, so it's a -6, which means when we reflect, we're going to have a point on the reflection, which is a -8 and a +6. That's what it means. Okay, and that's just the beauty of having a clear, thorough understanding of your theoretical concept. I promise you, if you can invest in understanding, that's what we call conceptual understanding. If you can invest in your conceptual understanding, not just how, don't rush your interest in mathematics, in learning mathematics in the classroom. Your interest should not be, how do I answer this question? How do I answer this question? Your interest as a diligent math student should be why. Why does this function behave this way? Why are we answering it this way? Why are we doing it this way? If you can be that curious, I promise you 60% of this stuff will be easy, very much doable. Okay, that's about it as far as the parabola is concerned. We're going to talk about the exponential. In fact, I've spoken about the exponential graph at length, okay? I just want to remind you of the definition so before we jump into the question. So here, I'm not going to go to the theory. You need the theory, just visit the YouTube channel. There's a video there from last week's session and the session before. It has the lesson where I'm actually explaining this. So I just want to remind you, when it comes to the exponential graph, we've got this definition that says, if I have x is equal to a to the y, right, then y must be log x base a. And for a while, there was a lesson where we just spent time playing with this definition, where I gave you an exponential equation and you had to change this to a log equation. And I believe we did the vice versa, where I would have given you the log equation and you change that to an exponential equation. It is equally important to know how to do the reverse, both, okay? And I think we actually dealt with that definition again. So our definition has two parts. It has the one part where if you are given the exponential form, you want to convert to the log form, this is what you do. But then it will also have a second part where if you have a log function and you are finding the inverse, so hence x is the subject of the formula here, then you know that y will be a to the x. So part 2 is your conversion from log form to exponential form. Part 1 of the definition is your conversion from exponential form to log form. All right, so that's just what I needed to address. Let's have a look at this question and see how best we can deal with this. So I'm told here the diagram below shows the graph of f of x is equal to, watch this now, negative log x base c. I just want to bring something to attention. When I gave you those equations to play with, there would have been an instance where we dealt with an equation like this. And I said, this equation can be seen as this, a half to the x. And it's important to note that when we change this to a log form, there are two ways to represent it. One way will be to have it as negative log x base 2, but another way will be having it as log x base half. And I showed you that. And this question is definitely going to test your understanding of this little discussion here which we had. So I urge you once again, it is very critical that you remember what we did previously, because as we advance, we will be building on what we did previously. Okay, I think once I finish this function and inverse story, I'll be talking about calculus with you guys before we do advanced questions on functions, because those questions tend to talk about the derivative as well. So I think next week we will just jump into calculus section. All right, anyways. Now, let's read again. Let's make it a habit, math student. Make it a habit that when you look at a question and there is a diagram, before you even rush to the diagram, read what comes with the diagram. This opening statement is very important, and students often leave it out with some important information, and then they struggle with the questions. And then what the teacher does when they come to them, they just read the question and they're like, but do you see you are given this and this? And the student is like, huh? Oh, wow. But there's really nothing wow. It is just a matter of reading. So please, guys, I want to beg you again, and I will always beg you, make sure you always read. And as you read, of course, make sure that you understand what you are reading. So we are told this diagram below. Now, that's when you can look at the diagram, because the opening statement says there's a diagram. Now, what does it show? It tells us it shows the graphs of f of x. And again, you see the examiner is very nice. The examiner does not expect you to guess which graph is f. They have told you which one is f. So this is f. So again, these labels are not just given by accident or for vibes. We're doing this purposefully to actually help you answer the questions correctly. And so we know F, we're dealing with yellow. Then there's G, dx squared. This is the parabola. Watch, this is the opposite of what we just did. This one must exist on the positive x-axis. Now, I want you again to think of the theory. If this parabola is existing like this, and obviously it's a happy face, it means if you're going to calculate the value of D, you must get a positive number. Like this is, I hope as I repeat this, you are beginning to appreciate knowing the theory of functions. So this is the beauty of it. When you know this theory, you actually get to do well. Now let's find the values of C and D. C is in the log form. We find that using the log, and then D we find that using the g of x, which is the parabola with a restriction. You see, I did something bad here by not finishing off the statement. The statement goes on to say, the point P with coordinates half and half, listen to this, is the point of intersection of the graphs of f and g. And again, I want you to just, it's always nice when you know your theory, because you can play around with this. If I've got the point half and half, in other words, where the x value is equivalent to the y value, you know what that means? That means the line y is equal to x, which is your line of reflection, also passes through that point. The line y is equal to x is a beautiful line, guys, because that's the line where the coordinates are exactly the same. You have a -2 for the x, you have a -2 for the y. You have a +7 for the x, you're going to have a +7 for the y value or the y coordinate. That's the beauty of the line. So again, you see, just knowing these little facts, you end up being able to play around with stuff. You just get to have fun answering the questions. So we're going to calculate, we're going to determine the values of C and D here. And that's question 6.1. So we know for the log 1, we've got y is equal to minus log x base c. So what's going to happen here? I have a point, you see. They did not just forsake me. I've got a point, half and half. Now, how can I answer this, you ask? Well, let's go to your definition. Let's look at your definition. What are you changing from here? You want to actually change this from a log form to an exponential form, right? You probably want to do this, by the way. You probably want to divide by a negative before doing all this. So remember, the half is your log number. So what you can then do is you're going to use the second part of the definition, which says, if you've got this, then you got that. Now, please pay attention to what is happening here. You see here, x was the subject. Now x is going to be in the exponent. Here, this was the log number. So this is going to be now your subject. So I just need you to pay attention to that in the definition. And it's at least here, initially it was a problem, but now at least there's a negative half and there's a half. So let's look at the negative half. The negative half is in the place of x. So the negative half will become an exponent. And the positive half, if you look at it, will become the subject. I hope you see what I'm talking about. So that means then this must be half is equal to, obviously the base stays the same. That's what we've got, right? Then the question then comes, what do we do after this? My question is, hey guys, do you know your laws of exponents? If not, you are in trouble. So anyways, if I've got c to the minus half, I got to think of this as c to the negative 1 raised to the half. And c to the negative 1 is essentially 1 over c. So I actually have 1 over c raised to the half in this instance. So this is 1 over c raised to the half. And by the way, there's a difficult way to do it, but I could have shown you the easy way as well, but we would still get to this instance. Now, what should I do to get rid of the half in the exponent? I got to square both sides. So surely if I square both sides, watch this now, then this becomes 1 over 4, and that becomes 1 over c. And it must be clear then from this moment that c is equal to a 4. Now let's write that down. Y is equal to negative log x base 4. And at this stage, if you are very uncertain about your answer, you are actually welcome to punch this in the calculator and see whether you'll get the same thing. If you type negative log, I need to enter base 4, so I'm going to use this, of a half, you are anticipating to get a positive half, because I'm just trying to prove that point P is indeed here. Or I'm actually trying to prove that I have the right value of C. So then you know you got the right value for C. So C is indeed A4. And then when it comes to the value of D, there's an easy one. This one will probably be 1 mark, still on 6.1. So if I've got Y is equal to, let's use a different color for this one. So if I've got Y is equal to dx squared, then this is a half, and then that's a half. Remember, it must be squared, and when you square a half, you get a quarter, 1 over 4, and that's that. And then you're going to multiply by 4 both sides, so d will be a 2. That's it. You just need to find the values of C and D. So actually, this step is not even necessary because you have the value of C and you have the value of D. That's all you needed to do. Right. Then the next one, the equation of the inverse in the form. The inverse of what? Of G. This is the inverse of the parabola. So you could use your theory actually to do this, but it's fine. I guess you could go, okay, theory, I have forgotten you. So let's just do this nice and quick. 2x squared, let's swap x and y because we're looking for the inverse of G. And so now y will be, watch this again. I'm going to skip a step here, but maybe it's not good for everyone. So I get y squared is equal to x over 2, which means y is plus minus the square root of x over 2. Now you got to decide, what am I going to choose here? Remember, your inverse for the parabola, if it was complete, it would have looked like this and then that. So obviously, in this case, this part here will fall away. So we're not going to take that. We know the inverse is going to be that part, and this part is on the positive y-axis. And because it's on the positive y-axis, we have then to take the inverse of g as the positive square root of x over 2. And obviously, even for this one, we're going to take positive x values. Then the next one that we're going to do is we're going to find the inverse of h, which is basically the inverse of the log, which is the exponential, you see. Oh, by the way, I think we need to read this question carefully. The equation of h inverse, if h is a reflection of f in the x-axis, So it's a very interesting question, because what the examiner is trying to test here is, do you just rush to answer a question, or do you actually spend time reading the question? Okay. What most students would do here, they would just jump to calculate the inverse of f. And students will just ignore the fact that you are not given f, you are not required to calculate the inverse of f, but you are required to calculate the inverse of h. So I just want to bring to your attention, and let me just do this. I just want to bring to your attention before I answer this one, the fact that just because you have seen a certain symbol in a previous question, it does not mean the question will ask the same thing. So it is important, again, it goes back to what I said. It is important that you read and you understand what is being asked. So let us read this and actually be deliberate about it, okay? We know that h, what is this graph h? H is a reflection of f in the x-axis. Now, f is the log function, and you have found that the log function is y, f of x equals to minus log x base 4. If I reflect this in the x-axis, then the y values are affected. In other words, this becomes h equals to log x base 4. What happens is that negative falls away. And I think I have discussed reflections as well. Now, because we now have h, we can now find h inverse using what? This h. So h inverse, then, let's start the process. Y is equal to log x base 4. Let's take, well, before we take the definition, let's do the swapping. And if I go to the definition, which is somewhere here, we know it by, I know we should know this by now, by the way. I hope you do. This will then be y is equal to 4 to the x. So then that becomes the equation of h. The last question then would go, what are the values of x for which the inverse is positive? Now, this is, you see, it's 1 mark. The reason it is 1 mark is because this is actually a knowledge question. Because as a matriculant, you started learning about the exponential function in grade 10. And you drew a graph like this. You drew a graph like 4 to the x, and this was the graph. This is how it looks like. So when is this thing greater than 0? So obviously, you should know by now that it is greater than 0. By the way, what does the word greater than 0 mean? In functions, when they say a function is greater than 0, it literally means it is positive. That's what it literally means. So when is this thing positive? So looking at this whole thing and the fact that you've done this since grade 10, you can clearly see that this thing is going to be positive for all real values of x. From minus infinity to positive infinity, this thing will forever be positive. There's no point where the exponential function 4 is to the x is going to be negative. That is what they're literally asking. In any case, more on this when we do some calculus and maybe some interpretative questions on functions. All right. So guys, this will be our story for today. I'm going to stop it all here. I don't know if there are questions, but I'm hoping there aren't any. But yeah, this will be it for today.